This is number 17 from the lecture examples. And in number 16, we found that the empirical formula for our compound was C7H14O. Then in number 17, it tells us that the molecular to find the molecular formula, given that the molar mass, so the molar mass is equal to 228.375 grams. Now, just to recap, the molecular formula is always a whole number multiple of the empirical formula. So, and it could be, I mean, if this formula would add up to be 228.375 grams, then this would be the molecular formula. So, you know, sometimes like CO2, CO2 is the empirical formula, CO2 is also the molecular formula. So anytime you are working a molecular formula question, you are going to take the molar mass, divide that by the mass of the empirical formula, or let's call that the empirical mass. And that's going to equal that multiple. How many times the empirical formula is going to get multiplied to equal the molecular formula. And we can call that the factor. All right, the factor by which we will multiply it. So for instance, if we would divide the molar mass here by this empirical mass and we would get 3, then we would multiply all of the subscripts here by 3, making it C21H 3 times 42 and O3. So that's what we need to do. So we need to figure out what is the mass of this. So it's 7 carbons, each at 12.01. It's 14 hydrogens, each at 1.008. And it's 1 oxygen at 16.00. And I think that adds up to be... $114.182. So working our formula, the molar mass is 228.375. We found the empirical mass to be 114.182. And so divide those, it's going to come out to be a factor of 2. That means to go from this empirical formula to the molecular formula, everything, all of these subscripts will get multiplied by 2, leaving us with a molecular formula of C14H28O2. And that would be our molecular formula.